So what I'd like to introduce is Adam from Tropo. Now, we've known each other for like 3 or 4 years now, and this is actually the first time we've ever physically met. So it's great to physically meet you finally.
I've avoided it this long.
Now, Adam's going to be presenting on something slightly different to what's in the agenda. So he's going to be focusing on the use of cloud in telecom service innovation. So with that, I'll just hand over to you, Adam. You can stand up here and present. Here's a clicker. And there's a speaker here if you want to walk around.
Great. Thanks. My name's Adam Kalsey. I'm with Tropo. We make APIs to enable carriers to easily expose their core network to developers. So traditional telco looked a lot like this. You had specialized hardware and software. If you were building applications and deploying anything, not that long ago, you had to deploy some special software in there. You maybe had to deploy hardware. If you wanted a voicemail system, you ordered a refrigerator-sized box and brought it in and plugged it into the network. Anything you wanted to build, there were very long build times involved, included a lot of safety and security reviews to make sure that the application being delivered was safe for the core network. I mean, it wasn't that long ago that in the United States you could not plug a device into your phone jack inside your house that wasn't supplied by the phone company, and it was illegal to do so. It also required a lot of very deep domain expertise. You had to understand telco and understand how signaling worked and how telco actually worked in order to build an application. So if you wanted to build an application, you had a calendar sitting here and you started mapping out what it was going to take to build it. You'd go through and you'd say, okay, this is what my development cycle is going to look like. It's going to take this long to build it. So if it's going to take that long to build it, well, now I need some QA on the end, so we're going to tack that on there. Now we've got the security and safety review and get those guys to build that. When you're done, you've got deployment and rollout that you're going to have to do to put that together. So backtracking from there, okay, well, we need architecture and how are we actually going to build this and where are we going to put it? So that's going to tack some time onto the front. You're going to have the planning and the project management involved, and that's going to tack even more time onto the front. Hardware procurement's going to take at least a couple of weeks, and that's if somebody's already got that sitting around and ready to go. And then, because we've got this huge amount of time involved in this, we've got to make sure that this is going to make money before we invest months and months and months or even years into this. So we're going to have to spend a lot of time up front building out a business case. So from that, you end up spending a lot of time creating a sales forecast and a business case. You start bringing people on board, lots and lots and lots of people on board. You start building out a server. Now, well, I'm not going to be able to do it with one piece of hardware, so I'm going to add some more hardware and add lots and lots and lots and lots of hardware. So this was a very expensive and has been a very expensive process to build any sort of service innovation, whether you're talking about an operator building something internally or even opening up to a third party that comes in. If you want to go to, if you're a package delivery company and you need to innovate some communications and you've got some ideas on how to bring real-time communications into your business offering, go to the carrier and ask to do that, and these are the types of sales cycles that you're looking at. You're talking about months and long to build that out. So Mark Andreessen, the creator of Netscape, has recently said that software is eating the world, and that's really happening in telecom as well. So instead of having all of these pieces of hardware and all of this stuff that you're building, now you're bringing in software, and that's going to help a lot. So you've got IMS. Now, IMS has come along and it's helped, but if you're not a telco guy, this probably doesn't look like a simple architecture. This is a simplified view. This is the Wikipedia-ized view of what IMS is and how that gets built out. This is what a simple IMS looks like. IMS has helped. It's helped a lot by bringing the world of software into telco. It's helped a lot by exposing operators to the idea that not everything is hardware and routing and things like that. But it's provided a lot of APIs. And those APIs, that if you're going to build an application on IMS, you're building out basically the IMS application server, very, very low-level APIs. The APIs are SIP. You have to understand the telco, you have to understand exactly how that particular telco works, how it's deployed, and those low-level APIs are really still for experts, and that's who's using these. We have a customer that we started talking to them about providing developer APIs, and they said, well, we have a third-party API program, and we have developer APIs for doing voice APIs. Excellent. How's that working? Well, it's SIP. We expose SIP to our own developers. Okay. How many developers do you have? We have 8. 8 developers. Someone else in the room goes, well, no, not really. We have 1. We have 8 people who have signed up, but only 1 has actually written anything. Okay, so what kind of traffic do they have? Well, they didn't finish because they had to know SIP. So you get these low-level APIs. Now, this is the engine of a car. You're probably not going to operate a car by sticking your hands in the engine and monkeying around. What you're going to do is you're going to take a higher level API, you're going to take a higher level interface and expose a lot of the simple things that you'd want to do with a vehicle into that car. So beyond just taking a simplified API, simplifying the language as well. So you want to lose that domain-specific language, lose the things that are required for a developer to understand the telco and understand a telco-specific language. Start bringing that out to web developers and exposing web development languages. One of the things that you'll discover is that web developers are a little bit different than a telco developer. They're not what you're used to seeing. They're expecting things to be a little bit faster. They're expecting things to be a little bit easier. They're expecting documentation to be sitting there available to them, a sandbox to be able to use, lengthy registration, sign up, let me negotiate with the carrier for 6 months before I get access to deploy anything and test anything. That's just not going to work for them. They're used to building in an environment where they can set up a sandbox, they can deploy, they can write a simple bit of code, and in 5 minutes actually test it and say, hey, this thing kind of works, this is cool, let me play around with it more and do more things with it. So as you're providing these APIs, one of the things that providing the APIs to and well-defined list of APIs beyond just an IMS app server, but building those APIs on top of that is you're able to provide a lot of safety as well, and you're able to satisfy the internal approval cycles and the internal processes much simpler. And so you've provided APIs that are pre-vetted, pre-approved. The safety and security teams, the operator, everybody within the operator understands what the APIs do, what level of access is required, what level of access to the network they have, and where those boundaries are. So rather than just taking an app server and writing a telco API or telco product and dropping it on the network where that product can do anything, there's a very limited subset and a very restricted subset of things that the application can do. That makes the security guys a lot happier because things are sandboxed off. That makes the compliance guys a lot happier because things are signed off or sandboxed off. This has nothing to do, I just love the picture. There's really nothing to do with the presentation here. You've got one of the advantages of providing APIs and using the cloud and using cloud deployment is the carrier controls the quality of service. So things like how does the application scale? How many users can run on the application? What's going to happen as the application reaches up to the maximum amount of time? All of that stuff happens and is controlled by the carrier. The developer is just worrying about their application, the business logic. What does the application do? They simply deploy it. So an example using Tropo and using our APIs. So this is taking kind of an entire set of the network. You've got the IMS or a switch network sitting up there on the right. Going down through the Tropo APIs, the developer code runs on a platform as a service. So sitting down here, separated off from the core network, we've got a platform as a service that manages the scaling, that manages the uptime, that manages the security, and it's running inside the carrier network, but not physically, it's physically and logically separated away from those core network assets. So there's some safety here. A developer can't write rogue code that's going to interfere with the network because it's separated off and it's only using the APIs that's allowed to use. So once you start taking these APIs and you start taking platform as a service where the developer can write code, rapidly self-deploy it, without those lengthy necessary security reviews, without the processes and things that are involved typically in deploying something. And you start then using concepts like cloud provisioning, so that when you order hardware, rather than ordering 50 boxes, you order a VM through an API, and instead of taking a week per server, it takes a minute or 2 minutes per server to spin those up and bring those online. What happens is you take this big lengthy cycle, and you say, okay, well, I can develop faster. I've got simplified APIs, so I can write that faster. So I can reduce my time for development down. Since I've reduced my time for development down, now the QA time required drops down. Those known risks, the risks that the application can have are well known, so the security reviews shorten or completely go away even. The deployment becomes shorter because now it's controlled by the application developer. It may even be a push button process where somebody says deploy this, and the application launches either into a sandbox environment or into a live environment. Your architecture can be reduced because all of the architecture is now about how the application works. Now you've gotten rid of how does it connect to the network, what does it do, what resources does it consume, what resources could it impact. All of that kind of stuff is abstracted away. And your overall dev cycle is shortened, so now you need less planning. Your cloud resources mean that you've got instant procurement and provisioning of hardware. And now, because you've got all of those things and all your development is shortened, that business case can be less robust. Your project cost is less, so you don't need to spend a month predicting if an idea is going to be viable, when you can simply just build it and deploy it and test it with developers and find out in a month, which then allows you to take a lean startup approach, an approach that a lot of developers outside of the operating world are taking, where they're testing things and testing with real users rather than doing case studies and market surveys and all of that sort of thing to build things. If you can test an idea cheaply, instead of planning ahead of time and planning out ad nauseum what's going to happen and what the world's going to be like a year and a half from now and what people might like, you can actually simply build small iterations, try them out, throw them out there, find out what works, destroy things that didn't work, get rid of it. The cost is so much cheaper to do these deployments. So once you've done that, what does that do to your timeline and resources? You may be able to shorten the entire process if you're doing these small iterations into a very, very short period of time. So this isn't all about third-party developers and deploying this out. One of the things that we've seen happen a lot is developers or operators say, I need to get a slice of this third-party developer pie, and there's developers out there and they're using APIs, and I want to get in on that, and I want to use part of that. And the reality is that a lot of developers aren't going to look to an operator and say, boy, I really wish I had a way of doing payments, let me go talk to an operator, because there's other simplified ways of doing that, and there's the developers, if they have worked with an operator before, they've discovered what a painful, difficult process that can be, and they say, well, I don't have that kind of time to build that out. My whole prototype cycle is a month and a half. I can't spend 6 months waiting to see if we can work with this developer or with this operator and maybe not even have that happen. And one of the reasons that cycle exists is the operators don't understand how to work with this new type of world, how to work with this world with quick iterations, quick deployments. So one of the things that we see happening, and it's been a successful model, is internal product teams are the first customer of these APIs. You build out the APIs, you build these pieces out, you let internal product teams build stuff. A lot of these internal product teams, they've got ideas and they've got this pent-up demand for services and products that because of these huge lengthy development cycles, they weren't able to implement. So things like mobile call recording or compliance monitoring, parental control, call management, who can call you and when. All of these things, there's demand from the consumers, from the enterprises for these services, but operators haven't been able to deploy them quickly. So by allowing a product team to be the first one to use this, you're going to learn from there, where are the boundaries? What does the security team allow us to do? What do we need for billing? How do we deploy a new service on a phone number? How do we provision these numbers? The next step is, once you've proven those platforms and you've figured out the billing and the provisioning and all the processes and all of the things that are there, and you start understanding those, the next step is to open these up to trusted third parties. These may be systems integrators that you're already working with. It may be large enterprise customers that you have a strong working relationship with, or it may be established consumer products and enterprise products that are out there that you can easily deploy and use. So you may go out and talk to, Salesforce or LinkedIn may need some of these, may need communication services. You can deploy those, offer those out to customers. And then the final phase is, once now you understand billing, now you understand what type of security and what external developers need and people who aren't sitting in the room with you are going to need, now you can open this up for registration by third-party developers and start allowing anybody out there to use this.
Excellent. Thank you so much, Adam.
Thank you.
Do we have any questions for Adam? Again, what I thought was really interesting is there was a great alignment between what Amos presented earlier in terms of their approach and what you're recommending here. And I like the little calendar graph. That demonstrates it very well. If not, because we are behind time, again, thank you so much, Adam, for an excellent presentation.